let me introduce myself. I am Talha Salman and I lead the Developer Student Clubs community in UET Texila. It's situated in District Rawalpindi in Pakistan. And today we're going to talk about data, AI, ML, and then we're going to see how to register for CloudSeekho. CloudSeekho is a self-study program, and we'll go into the details later, and we'll also solve a hands-on lab. We also have Mr. Munib with us. He is our moderator, and we have a special guest today. All of you probably know, but we're going to introduce him in a few minutes. So first of all, let's see what is data, what is AI, what is ML. So we hear these words almost daily now, especially at least the people in the who are studying in IT. So data is basically, there's a lot of information being produced daily uh, all around the world, and there is some limitation to how much a human can process that data. So that's where data science comes in. So the combination of the tools and techniques that we use to analyze that data, those random clusters of data, and then trying to extract information out of them, trying to make sense what the data is, that is data science, and in short you can call that data. And then comes AI and machine learning. So this is, you can say they're specific, or they're specific applications of data science, but first we'll see what is AI. So AI is basically enabling the machines to reason, giving them the ability to reason, and then trying to replicate human intelligence. And our main objective in artificial intelligence is basically to teach a machine uh, from experience and how to reason. And now machine learning is a further subset of artificial intelligence. So in this, we create a model that observes data, and then it identifies patterns, and then it sets up a reasoning algorithm to identify things uh, and such. But hey, I'm not an expert in machine learning, so uh, we have Mr. Stephen, who's a Google developer expert in machine learning, and you can take over, Stephen, now, and you can tell us everything and all about machine learning. So
Okie dokie, very well. Then let me get this down in place, and I will begin sharing my slides here real soon. All right, so
really
present.
excited for today. Uh,
Excellent, excellent. Yes, so my name is Stephen Wylie, and I'm a Google developer expert coming at you from Dallas, Texas. And so it's actually 9:38 in the morning out here from Texas. And so, hopefully, through the magic of the internet, you guys, we can all come together and we can talk about machine learning and have a really great conversation out here. With the Google Developer Experts program, it's basically my job to go out and speak to a lot of different people on the topics of machine learning, even beginner all the way up to advanced topics. And so we make presentations, we make content. There's code repos, the repositories, and examples, and blog posts, and just about anything you can think of that kind of goes into all this stuff. And so we love going out and presenting to people, and especially to the young folks in universities, because we know it's you all that are going to come up with the really great, amazing, big technology in the future. So we hope to be really inspirational to you all and get you really excited about this topic. So on that note, I would like to start out by introducing you to Mountain View, California. This is on the west coast of the US, and this is where Google has their headquarters. So they've got a facility called the Googleplex, which consists of dozens of two-story buildings like this one. Some are nice and some are kind of drab, but then if you go across the street roughly from this Googleplex, you'll find another building called the Computer History Museum. Now, at the Computer History Museum in Mountain View, they have a lot of different computers on display that were built during the first half of the 20th century. And when I was going through and looking at all these strange, old-timey computers, one thing really struck me as kind of odd and fascinating was that a lot of these were used for solving differential equations. They weren't the general purpose computers that we know of now, but they're really just cranking out math equations constantly. And specifically, these math equations were being used for calculating ballistics projections, how to shoot missiles and how to shoot projectiles to wage more effective war. Well, it's kind of a limited application, and I'm sure that a lot of researchers and computers wanted to do something, more humane than that. But unfortunately, that's kind of where the money was during the first half when we were fighting all these world wars. Fortunately, though, as the Second World War ended, mathematicians and researchers began trying to model many other aspects of the world around them. So, while you can model the path of a rocket with physics equations and stuff like that out of a textbook, well, it's much harder to teach a computer to detect specific objects out of a scene. So, for instance, if you wanted to show a computer a picture of a tank in a forest, well, how do you go about trying to detect that tank? Well, that's pretty hard. There's no kinematics for that, and certainly there's no kinematic equations out of a physics textbook that can describe the odds that someone will like a cat video or react to a marketplace listing for sale and potentially buy the thing for sale. Well, this is the basis of artificial intelligence. That is, training computers to possess the intuition that we have as human beings based on input from our five senses to solve complex problems like we do. However, actually getting AI to work stumped researchers for decades. Well, over all this time, including several boom and bust cycles in the industry that have passed since the dawn of artificial intelligence on computers, well, there's two things that have recently changed. One, powerful computers, and two, nearly endless data. By the way, this was my slide about not doing kinematics anymore. We've gone way beyond the physics equations out of the textbook, and we're solving for much more complicated things with artificial intelligence. So anyway, as you can see, we've got really fancy computers in the data centers, and you've got various types of data as well. You can see kind of on the screen on the top right is what we might call unstructured data. That is just dumps of usually server logs or just streams of information coming from sensors. You might have some kind of, at the very least, time series data, for instance, where you're getting measurements off a particular sensor. There's the server logs, as I was explaining. But in essence, it's not really categorized into anything in particular because it's not got columns to it. And so you don't really know what each message is pertaining to necessarily. It could be an event where somebody logs in, or it could be an event where some process crashed or something like that. Then kind of down at the bottom, of course, is your typical database type of scenario where you've got obviously massively structured data. You've got sale ID, sale amount, date, product category, all this kind of stuff. And then at left, and that's kind of the bottom center, you've got these graphs, which could potentially be also either structured or unstructured data, but it's a dashboard from Grafana. And Grafana is a really cool tool that a lot of tech people use to monitor their systems. But to interface with Grafana, you typically have something that can parse these unstructured logs and pull the relevant data from them. So, it is possible to interface with all different kinds of data out there as you're going about trying to do machine learning off of it, or even just trying to figure out the status of something and see how often it's doing something. There's a lot of different steps involved with this stuff to really make it work. But I would say over all this time that's passed since the 1950s, when people first really started looking at artificial intelligence on computers, well, a couple of massive things have changed just recently, in the last 10 years or so, I would say. One of which is really powerful computers, like the kinds you're seeing up here. The massively scale up and scale out types of server computers, especially from data centers, and available to you on the cloud. And then as well as nearly endless data, because storage is cheap. So there's really, a limitless capacity for storing any kind of personal interactions or information about astronomy and where stars are in space, kind of like the sky's the limit on that stuff. So I want to say that just 10 years ago, when I was doing my master's in college, my university had a shared workstation with an NVIDIA card, a graphics card, so to speak, and it was containing just 30 CUDA cores in it. The CUDA cores are doing the massively parallel computation. And so, for us, it was a big deal at the time to be able to do our row reduction on our matrix and be able to do this in parallel with 30 CUDA cores. And yet 5 years later, like middle of 2015 or so, I was able to then go to Best Buy and buy myself an NVIDIA GeForce 570 Ti or something like that. And at that point, it's a stock card. It's only a couple $100. But from there, all of a sudden, 30 CUDA cores seemed like about, the complexity of computing on a wristwatch, because now I had 2,400 CUDA cores. So big jump in the computational capacity of these machines just in that 5-year time span. Now, fast forward that to nowadays, where we've got cloud computing that allows you to orchestrate these massively parallel types of computers involving not just big CPUs like the big servers you see on the slides, but also GPUs, huge racks of these NVIDIA Tesla cards that are optimized with many thousands and thousands of these GPUs, the CUDA cores in them particularly. And so the CUDA cores, it facilitates the massively parallel types of computation that you can do to really get this stuff going fast. And then, of course, even then, we've developed specialized hardware with Google doing their TPUs, or tensor processing units. Of course, TensorFlow being the open source machine learning framework, it would follow that then they would call it tensor processing units for their specialized hardware. So with that, you've got the more capable compute, including the CPU, the GPU, and the TPUs. And then from there, you've got all this wonderful pre-built models that have been done before. And some of these pre-built models include things that will do image classification, object detection, natural language processing, and even analysis of content in videos, for instance. And so that's pretty cool that there have been people that have created such complex models and trained them on just unimaginable amount of data. It's staggering just how much training goes in. Some of these things have been running training for months and months and months. And you can download these pre-trained models and deploy them. And then basically, you're already set. There's not really a whole bunch more you need to do from there other than give it the thing you want to classify, and then it gives you the answer. So that's pretty cool. And then from there, there's, as I said, the architecture is available for processing all this stuff. Now, one thing that I want to caution you about the pre-trained models is they come with really generic things that they can do. For instance, you've got ImageNet as one of them that can do object detection. And with ImageNet, it can classify about 1,000 different items that might appear in an image, which might include things like furniture or pets or certainly people, or maybe even things that people might wear or objects on your desk. But it's not going to be able to specifically, say, recognize different models of computers that you might have. Like you've got a Lenovo or an Acer or Dell or Chromebook or whatever you might have. It's not going to be able to be that distinct. So that's where you do definitely have to go train your own models for this kind of stuff. But the cool part is that a lot of these models are available if you want to play with them in the code through a website called TensorFlow Hub. With TensorFlow Hub, you can go in and you can download the model, and there's ways that it describes in terms of how to retrain these models using a lot less data and in a lot less time on the categories that you care about. So that if you want to make your laptop classifier, or if you want to make some kind of video game classifier that can distinguish the difference between, say, Sonic 3 or Super Mario Brothers or stuff like that, then that's the way that you would go about it. Of course, there's ways through the cloud as well to do that too that doesn't even involve touching models whatsoever. So speaking of cloud and what that has to offer, there are development tools that are low code or even code free at all. So you don't even have to write code. At the very minimum, you would basically be using Postman, for instance, which is a program that you can download to interact with various APIs, that is application programming interfaces, so that you can make a request to a server with specific data, and then the server will come back to you with the answer. And in fact, the server can be storing a machine learning model in it that can tell you information about what's in the picture. In fact, I think you'll be doing this in a bit with the Google Cloud Vision API, and so you can get all sorts of data from the Cloud Vision API. In particular, you can see what's in an image, potentially who's in an image, if there's celebrities in the photo. You can find out if there's corporate logos. You can find if there's text. You can do basically text recognition as well and do OCR on it, the optical character recognition, convert it into words, and it gives you the bounding boxes for a lot of this information. That is, it will draw a box around the part of the image that contains what it is that you want. It returns those coordinates in case you want to crop it or do something else with that later on. So I would say there's no need to be a machine learning expert just to deploy machine learning. There's plenty you can do with it now in its current state, which is super exciting because it unlocks people who are not necessarily experts in the field to unleash their creative potential and to do something really cool. And that's why I think that we're in really the golden age of machine learning, because it's getting to the point now where basically anybody can do this. And so I love it because we're going to see, whatever matters to people start to become prioritized with developing with machine learning. So you can do this kind of the middle of the road approach using Cloud AutoML, where basically you're still not really writing code, but you're also getting a custom model built for yourself. And so with Cloud AutoML, allows you to put information on the Google Cloud Storage buckets. If you have a set of images that are cats, a set of images that are dogs, then it goes through and will say, all right, we're going to build a model, and it'll tell you a cat versus a dog. So that's pretty exciting. It'll still give you the level of specificity that you want, but you don't have to write any code still. The next thing that's cool is the cheap storage with nearly limitless data. And on that note, we've got public data sets from Kaggle that you can use. If you haven't heard about Kaggle, that's another website where you can download a whole bunch of open source data and you can play with it. You can make models based on it. You can visualize it and graph it. In fact, they even have contests where you can build up your data science chops and try to perform analysis and do the best machine learning algorithm off of it. And they have contests that are exciting, and it can really build up your credibility by participating in those contests. And so it's pretty cool. So basically on that note, before we leave, I just wanted to say that the cloud computing is really cool because it lets you tap into such large machines and computers that are basically set aside to do the most complicated processes that you can think of, and they're doing this day and night. But now as we move on, I want to talk about some of the learning types involved with machine learning. You've got supervised learning, which is very common. You've got labeled data, kind of like the database example. So for instance, all the attributes and all the outcomes are described. So for instance, if you have a credit policy, so you've got some notion of, all right, there's a person, they've got a credit score, they've got kids, they've been married, they own a house, they make this much money a year. Kind of like what are information about them? They've got a credit score, they've got, current debt that's outstanding. All right, so knowing all this, are we going to give them a loan? And if so, how much and for what interest rate? Those are the outcomes that we want to figure out from this set of data. The good news is we've got previous history on what people have done. Here's their variables, here's what we gave them, and then did they pay it or not? And then knowing all of this stuff, we can build models to decide whether or not to give people a loan in the future. And so from all of this, then you can build stuff like decision trees or even neural networks or a lot of other types of supervised algorithms. Then for unsupervised learning, well, not all examples are labeled, or perhaps they're going to be clustered together in groups. And so when you've got groups like this, then maybe you're trying to do some kind of detection of anomalies. So you got maybe a router that's doing traffic analysis on a network, and so it's trying to detect denial of service attacks. And so you can see, all right, there's these typical traffics that are coming in over HTTP from specific servers. Those are all right. But then if something weird starts to happen, you can say, all right, this is out of the normal, or this is definitely spam. This is over here in the spam category, and so you can alert somebody to either shut that off or to let it through because they can do some analysis and decide that it's correct. Thirdly, there's reinforcement learning, which is where computers will do a task over time, over and over again, and observe the outcome and then compute the score of it. Now, with reinforcement learning, this is usually where you find people that have trained computers to play video games, such as Mario or Breakout or so forth like that. Now, I want to go through some examples of machine learning problems. One is you've got classification. And this is pretty straightforward. You basically maybe have an image model that's trying to pick an animal that it is, or certainly if you've heard of MNIST, that's MNIST. That was a model designed by the US Postal Service back in the early 90s when we were trying to classify handwritten digits. The handwritten digits were important because people write somebody's zip code on a letter, and you use that to know where the mail goes. And so, doing this by humans was just taking them a lot of time and a lot of money. So they figured if they could build a robot with some vision, they could look at a piece of mail and then determine where it goes based on its zip code. That would be a lot easier. So that's why the MNIST dataset was invented. And so if you see that, it is basically up there to give people a chance to build a model that can classify numbers of 0 through 9. And you see a lot of great research and performance coming out of that. Then, in terms of regression, this is where you actually predict numerical values along some kind of line. It can be linear, cubic, and stuff like that. So there's clustering, where we can group similar examples like I was explaining for spam detection, or for finding the most relevant documents in a search. You can find out which terms appear the most in the body of documents, and then based on the terms that appear, you can group them together and see, okay, which one should be related to that one. Association rule learning could be, in essence, forecasting as well, because you can infer association patterns in data. Now, I'm a new dad. I've got a 9-month-old baby boy at the house. And so, I'm buying baby food, and it's possible that these algorithms, the stores, know that I probably want to buy diapers too, because guess what? They're going to eat as much as they do the other things. So, unless I'm buying hugely in bulk, and there's a lot of things that I might have disparities in when I buy them, but it knows that I will certainly come back to buy both at some point. Then you got structured output, which is where you got natural language parsing trees. If you've ever diagrammed a sentence, that's pretty cool. Or like image recognition bounding boxes, like I was describing earlier. And certainly with ranking. You want to identify a position on a scale or status where you're doing like search result ranking. For instance, who's the most relevant page to your search? Now, one thing that's kind of cool about this is that you see that a lot of these categories might seem like they have a fundamental work associated with logic, formal problem solving, and heavy doses of mathematics. And there's still plenty of mathematicians and researchers advancing machine learning to develop cutting-edge models that are more accurate and can be trained faster. But the good news is you don't have to know a whole lot of math just to get started building something. So, I explained the AutoML tool. There's certainly the natural language and speech APIs and things like that. That's all you really need to know just to get started. And in fact, even if you do want to get mathy, there's still other ways that you can invoke, such as these genetic algorithms or reinforcement learning, where the model is trained and judged by optimizing a fitness function that grades how well it does its task. So in other words, you don't have to model how something arrives at the answer. Like, it's not like a regression where you say it has to be this, but you arrive or you model it based on how well it can come up with the answer. For instance, if it's playing Mario, then how many coins did it collect, or how fast did it complete the level? And certainly it didn't jump through a hole and die, did it? That's a pretty dumb model to play a game with. And so, you want to grade the fitness functions appropriately in terms of what the end goal is instead of how you get there. Because that can be a lot less complicated. You let it figure itself out. Now, and so certainly here's an example of what the patterns look like in Mar.io and the connections that started to form in terms of when to hit the different buttons to manipulate the character on screen, the goodies, but also to avoid any of the death traps. You can watch a video about this online. If you're interested, it's pretty simple. You can look for MAR space I/O come up. So many of these algorithms are complicated, creative, advised, and these models provide then be fed into some sort of intelligence, processing which is near and my heart. finding arbitrary shapes in a pic. And see here, it's finding lines. It can be circles or hearts or anything else you can describe mathematically as well. You can use Puff transforms for finding lines, or Viola Jones for doing face detection, and then this is called canny edge detection, where basically you can find, for different levels of sensitivity, edges in an image in areas of high contrast. So all these types of things were state-of-the-art for decades, but it was a real struggle to use this edge detection to identify objects. People struggled for years with tedious feature engineering problems to find just the right way to represent something for an algorithm to recognize it. So, for instance, here's a person. The person can do something contrast images. Well, luckily, all this stuff has been superseded in importance. It's basically been deprecated by neural networks. So, really simply, you've got inputs that get transformed. You got this hidden layer that's performing some kind of computation, and then an output. Basically, it's linear algebra over and over and over again, trying to minimize the loss function in the output so that the output more closely resembles what the actual answers should be. So instead of doing a ton of feature engineering, a neural network decides what's important for itself from its training. And so if you have a concept that would be tough to model by hand, then with hours or perhaps days of training on tons and tons of data, they can learn to perform all sorts of complex tasks. For instance, whether a person is actually putting in or taking out a briefcase from a car, things that require some knowledge about time series information, what happened in the past, what's going on, what can we identify. However, these same models can often yield hilarious results when they're asked about something they're not expecting. For instance, I wanted to show you this too. So you have a real simple neural network on the left, but then Inception v3, which is used for image classification and telling you about objects that are in a picture, it is incredibly complicated. There's many stacks of these different layers that are convolutional layers or max pool concatenation, a bunch of stuff that really creative people thought of in order to optimize the problem of recognizing classifications in images. And so, you definitely want to leverage this work as much as you can. If you have to create your own, then you're probably in some institutional research setting trying to break records on performances of some academic data sets. But I think from the commercial perspective, we're not out trying to rewrite this kind of stuff ever. So speaking of hilarious results, though, I wanted to point out that you've got, for instance, so me on the right and then a couple other coworkers of mine were building a model that could detect vehicles. And, well, it turns out that we didn't tell it that there are pictures that don't contain vehicles in them. So as such, this thing actually classified, part of our faces and our bodies as being a 2010 Chevrolet Cobalt LT with a very, very low confidence, of course. It thought this thing was hardly a car, but, because we didn't threshold it, and because we didn't train it on pictures of things that are not cars, it still made a guess that it was, in fact, a car. So a model that only knows cars is going to try to think that everything is a car, which might not be the correct assumption. On the second case, we got this pretty funny picture, too, where a machine learning model might get tossed up on, is it a dog or is it a muffin? And so you got these images that really look the same. And that kind of lends us to a function called generative adversarial networks, or GANs, which is basically two neural networks that fight it out head-to-head. One of them is the discriminator and is trying to decide whether an image is a real or fake. And then you got the other one, which is the generator. And the generator is trying to make pictures based on, it starts out with noise, like random just jumbles of numbers. And then based on what the discriminator tells it, it adjusts the random noise until it comes up with something that can fool the discriminator. So this is how people make deep fakes, and they make, superimpose people's faces onto videos, or they possibly even make totally new faces that never existed in real life before. And so GANs are pretty darn cool, but it can also be kind of creepy in terms of what they're doing. Now, I like to consider neural networks as kind of a brute force approach to machine learning. Now, while they often perform the best in class at their tasks, they do very, very well, but they require lots of time and lots of data. And if you look at it, lots of energy. It kind of is a drain on the global energy ecosystem, kind of like Bitcoin wastes a lot of energy, and machine learning training neural networks can waste a lot of energy too, unfortunately. Now, I imagine there's smaller models that could be trained faster for many problems, but the problem is it's probably economically unfeasible to find a better model because neural networks are so generic and so high performant, it could potentially take decades more of additional research to find models that could do better on just a specific problem. So, unless you've really got some kind of economic motivation to do this, it probably doesn't make a lot of sense to try to do better than a neural network. So with that, just some other important points I want to talk about. There's model building. Might only be 10% of the big picture in terms of doing this kind of stuff. Because what you're really going to be worried about is getting good data to begin with. You want to collect data that's relevant and salient and make sure that it is representative of the categories that you want to learn about. And then also data processing and cleanup could take a lot of time as you go through and try to figure out, why isn't the model performing well besides hyperparameters and such tunables like that. It's important that, even my 91-year-old great aunt says garbage in, garbage out. So, she's old and she even knows this stuff too. So make sure you don't give it garbage. And you'll want to categorize the data ahead of time, make sure it's properly labeled. You want to potentially use such third-party services as Mechanical Turk. Now, I know that's a bad word around here because it's from Amazon, but Mechanical Turk allows people to get essentially classifications done for them for image analysis or for various other reasons. And so they can leverage the crowdsourcing data for them. So you don't have to sit there and do this yourself. It saves a lot of time. There's image augmentation where you can create, basically if you have an image, you can say, all right, here's transformations of that image, or here's blurriness, or here's different colors of it, or here's stretches, a bunch of different things. So you can get all kinds of different ways that a camera might represent something that you trained it on, because you never know what kind of quality or what kind of defects are going to be in things that people actually give to your model. You'd probably want some negative examples too, like I was saying, is it a car or is it not a car? That should be the first question you answer before you actually classify it being a car. And for natural language processing, it's usually important to do things like removing punctuation and stop words like the, a, and, etc. Those kind of words are usually not useful and can throw off NLP. Also, there's machine learning ops. How do you deploy a model? How do you make sure it stays running? A lot of times, companies like repeatable steps for automated deployments. You have Amazon, for instance, that's going to be deploying maybe every 11 seconds a new machine learning model. So, somebody sitting there doing that by hand would take forever. It wouldn't be scalable. And you also want to monitor for bad things happening, like maybe there's increased times to get a prediction. Well, that's not good. It's going to disappoint people with your performance. And so let's figure out why. Let's try to stop that. And so, as I said, it's a common problem for corporations. So then the other thing that's important too, that I want to emphasize to you now, is model explainability. Why does your model make the guess that it does? And as I was talking about credit policies earlier and giving people loans, well, there's going to be regulatory bodies and government that'll say, okay, why did you deny this person a loan? Does it look like you denied somebody because they're of a specific race or a specific gender or religion? Those, at least in the US, are no-nos. You can't deny somebody a loan based on, the kind of like the personality traits of a person or their race or gender or so on like that. And so you have to make sure that you can say that, no, it was based on, their hard numbers. They got a low income or whatever the case may be. So in terms of the AI and ML services, you got the building blocks. And the building blocks are probably what you're going to start out with first. There's the cloud APIs for web. There's the MLKit APIs for Android and iOS. This is where they have pre-trained models. You don't have to even really know anything about machine learning. You pass it in a picture or some natural language or some text you want to translate or stuff like that. You can even make chatbots with it, actually. And so basically you call Google's API and it comes back to you with the information. From there, a little bit more complicated, you got Cloud AutoML. This is where they've got APIs, or services rather, for image and video, natural language processing, translation, more tabular data. And AutoML Vision Edge, which is interesting because this one's actually for Internet of Things devices, like things that are out in the wild. They could be smart home devices, they could be on an oil field, they can be in a lot of different places. And so you can deploy models that were trained in the cloud onto edge devices. So these edge devices with their sensors can recognize patterns and do deductions on things that need to be done. This is where you bring your own data. You put it on the Google Cloud. Google Cloud trains the model for you. And then you get to deploy that model and then call it as much as you want to. And then finally, there's the AI platform. This is like driving stick shift. There's really, the sky's the limit. You have control over the code for every piece of it if you want to. You can manage notebooks to make your own custom models. And this is where you might put data in databases like Google BigQuery, for instance. And so from there, you can train a model on this kind of data, not just stuff that you put on Google Cloud Storage bucket. And then you can also go on and build all these other pipelines for explainability, deployment, monitoring, all that kind of important stuff. So I want to real fast go through the simple case. So up there on the left, you got the cloud APIs for web, and one of them is the NLP API for natural language processing. And this is the type of request that you would make if you use Postman, for instance. You'd make a JSON request, and the body of it's kind of look like this. You got a document. It consists of a language. It's got a type of plain text, and the content is exactly the document that is the words you want to send to be classified. And then the various features that you can extract out of it. You can get the syntax, such as nouns, verbs, adjectives. You can get entities, which would be like people, places, or things. You can get a document sentiment, which is basically how emotional is this thing? And is it a positive article? Is it praising something? Or is it a negative article where it's really criticizing something? And then, of course, you can get text classifications as well in terms of what the thing is about. And then encoding type is important. But all this stuff is actually documented at the natural language documents, the documentation part. So you can go through and pretty much learn how to do these things for yourself just by following the link. I kind of wanted to give you this one at least to get you started with it. And then finally, I wanted to not leave y'all without talking about Google Data Studio, because Data Studio is a really interesting way that you can make visualizations out of any data set anywhere on the internet, and especially your BigQuery data sets, and you can make stuff that looks really, really cool. So as you do machine learning, consider that visualizations and the way that the data appears can also be really interesting and really sell that story as to why your idea is important and what makes it sizzle. So with that, I think that's going to be it for me, and I want to say thanks for listening. And I see some questions over there on the side. I'll address those, I think, if we have time in a bit. But I wanted to say this is my Twitter handle, SWebCEO. My blog is goshtastic.blogspot.com. I've got a GitHub page at Mr. City, MRCITY. And then previous presentations I've given are at SlideShare. And my name on there is called Stephen Wylie 3. And so thank you very much, and I hope you enjoyed the presentation, and good luck with CloudSeekho.
Thanks a lot, Stephen. And if you're gonna stick around for a while till maybe 9:20, actually 9:20 in Pakistan, then we can answer all these questions that people have posted. So thanks a lot for explaining how everything works, and that will help us a lot in our hands-on part. Now we're going to switch. I'm gonna share my screen quickly.
Yep. Stop this. All right.
And yeah, so that was Stephen, a Google developer expert in machine learning, and he told you all about machine learning. So now you know how it works and how you train models and what types of models and how cloud helps you in doing all of that stuff. And even you can either do it all manually, or you can utilize APIs that have pre-trained models. But so do you really think that you know all about ML? So we created a short quiz that I think all of you might want to participate in. So I'm going to share the other screen right now, and we're going to start with our quiz. Well, Well, we have Shazeb, Ahmed, and Amna. Congratulations, you know a little bit more about machine learning and cloud than other people, and especially Shazeb. You got most of it right. So let's go over the answers now. So, what are the three types of ML algorithms? So everyone can check their answers. I don't think we can check the answers right now. Not until
Oh, I'll
we.
give it to you. So
Yeah.
basically, I'll say that the answer is structured, unstructured, and reinforcement. So basically, as I presented on that little clipboard looking slide, kind of towards the middle, you have the structured as being the ones that are like databases, and the unstructured are the ones that are maybe like system logs or just random dumps of information. And then reinforcement learning is the ones where you have machine learning models that are trained based on fitness functions, like they play games, for instance.
Right. The answers we could have seen the answers if the results compiled, but I guess we'll go with this. So then next we have, what is the name of Google's cloud tool that allows you to import your own data and retrain one of their existing models to make a new model for yourself?
Well, this is AutoML, or you can call it Cloud AutoML too, because the AI platform is, in essence, where you're building your own model. Usually, I guess technically you could say that you can pull in AutoML stuff as well, but really the answer I was looking for was AutoML. And the
Right.
cloud APIs are where you use their existing models, so you're not doing any training for yourself.
Right. And then AutoML is the answer we're looking for, cloud AutoML. And then comes, what is unsupervised learning?
Yeah, looks like most people got this one. So it's basically where you don't have any example labels, but you're more like trying to cluster information into groups to detect anomalies, such as, is this spam? Is this document related to another document? Kind of stuff like that.
Right.
You can
And
even do this with products and come up with recommendation engines as well for
oh,
products or movies or what have you.
yes, for people who were thinking about the real life applications, this is one of them, as Stephen told us. And then we have, what type of algorithm is used to train a model to play computer games? So I'm gonna answer this one. So and you're gonna tell me if I'm correct. So this is
Sure
reinforcement
thing.
learning, because we want to play the game perfectly. I guess that's the answer.
Which one did you say?
Reinforcement learning.
Yes, that's right. Reinforcement learning is that one. So the K-means clustering is an approach with unsupervised learning, and the generative adversarial networks is one that you use to make those fake pictures and basically fool machine learning algorithms into thinking something is what it isn't.
Right. The deep fake thing you were talking about. Uh,
Yeah.
and then we have, what is no longer so important to do when training a neural network?
Yeah. So the answer to this one is feature engineering. So basically, data consistency is very important. So you want to make sure that all the data is labeled properly ahead of time. Otherwise, as I said, garbage in, garbage out. Secondly, the hyperparameters are really important too, because this will affect, if you imagine, think about the Himalayas and think about all the different mountain peaks that are out there. If you imagine taking a ball and dropping it somewhere on top of the Himalayas, then, where is it going to roll to? In essence, what you're trying to do is find the lowest point, because that's when you minimize your error and you get the most accurate model when you minimize your error. So by messing with the hyperparameters, it's like messing with physics. The ball might roll really fast or it might go really slow. And so it affects, like, learning rate, for instance, is one of the hyperparameters. And so it can make for a more accurate model because you might find a better spot where there's lower error. But feature engineering is the one that is the answer, because this is where a human used to have to interpret aspects of the data and try to look for what's important and guide the computer to understand what's important. But nowadays, neural networks can build that information up for themselves. You have, for instance, the convolutional layers, which look like representations of parts of an image. You might have like a cat, where one of these feature maps might include the eye or the ear or something like that. And then it eventually builds up the whole representation of the cat. You didn't have to tell it anything, but it got it for itself.
Okay, so now we have, the next question is, let's see if you know something I didn't cover. So this was an extra question that Stephen put in, so to see if any of you know more about these topics about machine learning and stuff. So, what is the name of Google's tool that to help you make chatbots and conversational assistants?
Well, the answer to this one is Dialogflow. In fact, API.ai was its old name, but then Google bought them and then changed the name to Dialogflow. And Cloud AutoML NLP, while it does deal with text, it's not going to build you a chatbot.
So last year we had like CloudSeekho, we had the Cloud Study Jam, and in that we had a similar event in which we had got Qwiklabs access, and I'll be telling about Qwiklabs in a bit. And we actually did a few labs about Dialogflow in that, and we were able to make some conversational assistants. So if some
Nice.
people are joining us from last year, they'd know about this. Now we have
Yeah, that makes sense.
yeah. So, what are you more likely to spend time on besides model building in the real world?
Well, the answer to this one is all the above, because the model building is really not much of what you're going to spend your time on, but it's going to be making sure the data is accurate, making sure it fully represents all the classes that you care about classifying. And then in a corporate sense, you're also going to be looking to automatically deploy and monitor the model as well. And sometimes building up this pipeline can be a real chore as well.
Right. So, Stephen, can you tell us what is the Google tool that creates dashboards based on any internet connected data source?
Yes, this is, in fact, Google Data Studio. So
Right.
on Google Data Studio,
So you told us about the IoT thing. This is the one you were talking about, right?
yeah, this is, well, not necessarily. Actually, it's Google AutoML Vision Edge was the IoT one, because that's the one where you can train a model in the cloud and then deploy it to some edge computing device, like a tiny little camera sensor on an oil field or something like that.
Right.
Let
Okay.
me put this thing away real fast. I'll be right back.
Okay.
Sorry, I have to look like I'm in a conference call, but I'm just going to set that aside. All right, we can continue.
No problem. So, what is the model architecture used to generate new content by trying to fool each other into thinking an example truly belongs to a classification?
This is generative adversarial networks. And this is the one where you've got the discriminator, which is trying to guess whether something is the class or not. And then you got the generator, which is trying to fool the discriminator by tuning essentially random noise to look like something that the discriminator is trying to look for. And so it's kind of a two-part approach.
Right. Two neural networks going head to head. This is that one, right?
Yes.
One is trying to fool the other one into thinking that it belongs to that classification. So, the last question is, why is AI exploding in popularity now?
Yeah, I think pretty much everyone got this. It's all the above. You got the faster computers, much faster than you've had ever before. You got wider access to data. There's so much data being collected, and there's cheap storage for it too, so you might as well record it. And secondly, as y'all are about to take advantage of for this purpose, there's pre-built, pre-trained models that you don't have to come up with a complicated structure for. You don't need to train for like months and months at a time on billions of pictures. And then there's low-code ways to interact with them as well. Like you can just call an API with a picture. You don't have to specify any parameters about the model or anything like that. So you can really just dig in.
Right. So, we're done with the quiz, and now we'll shift back to the other screen. And yeah, I think you can see it now. So, thank you, Stephen, for explaining all the answers and helping us out with that. Now we move on to CloudSeekho. So, what is CloudSeekho? It's a self-study program in which you can learn on Google Cloud Platform, and the focus of CloudSeekho is basically data, AI, and ML, the topic of today's session. Uh, so you can what can you get from CloudSeekho? You'll get to learn all about data, AI, and ML, and if there's image processing and stuff like that. And also you've got this swag at the bottom. So you'll a bottle bag and stuff like that. So if you complete 6 quests, you'll get this stuff in the first row, and if you complete 12 quests you'll get a flash drive and a cup as well. All are Google Cloud branded, and this is for students in Pakistan, so I encourage everyone should participate in this, and you should share it with your friends. And how does it work? We'll go to that in a minute. And yeah, another thing, in CloudSeekho you'll get 1 month of access to Qwiklabs. The deadline for the swag redemption is 10th October, but you can use Qwiklabs for a month, so it's great for learning, for clouds and for CloudSeekho as well, and getting some of the swag, which is everyone wants swag. So I'm going to go to the next slide now, and so this is the link you want to go to every time you're going to uh, attempt a lab, because it has all the quests listed out, the ones that will count in CloudSeekho. So I'm going to quickly open this up, and I think it's time to share my whole screen now rather than just a single tab. I hope all of you can see it. um,
Yes, I can see it.
okay, great. So this is the CloudSeekho website, goo.gle/CloudSeekho. So it started at September 23. We made a lot of announcements, and I hope all of you are participating. And if you aren't, you should participate right now. You'll have till October 10th, till midnight, so you should participate. So what is CloudSeekho? So it is a self-study program, and it is for student developers in Pakistan. And I told you you'll be learning on Qwiklabs. You'll get free access, and Qwiklabs is a little expensive if you for especially for students, if you're trying to learn. But this is a great opportunity to learn on advanced labs that require more credits. So these are the available quests that that you can complete to redeem the swag. So there's image processing, language processing, BigQuery, and for data analyst marketing, Google Cloud, bracketology, TensorFlow, and we have other stuff as well. Um, and these are some of the advanced quests that you can do once you're done with these. And so what you want to do is you want to register, and I've already registered, so I can't see the form right now. But when you click this, you'll be prompted to fill out a form, and then you'll get an email, and it will detail all the steps that will be required to gain access to Qwiklabs. And I will explain that process briefly in a minute as well. And you can also watch this video. You can click this link, and you'll be taken to
Assalamu
this
alaikum.
video. So this is a video by Saad Hamid. Saad Hamid is the community manager for, well, multiple regions, but he manages the uh, developer student clubs community in Pakistan. So this is a video, and it's in Urdu. So I think everyone will be really this will be really easy to understand for everyone. So as I told you, six quests for the bottle bag, notebook, pen, badge, and stickers, and 12 to get the flash drive and mug in addition. Now, keep in mind the deadline, and you won't just get it by completing. You have to fill out this form by 10th October to redeem the swag. So this is the swag redemption, or basically the CloudSeekho Season 2 completion form. And yeah, that's pretty much all about CloudSeekho. Now I think we should get right into uh, the process. So I'm going to open up. Yeah, so I've already enrolled in this quest, but I'm going to tell you how to do this. So when you register, you fill out that form. You want to open this first quest, and you'll land on this page. So I've completed these two labs. Yeah, I'm not lazy, but I had a lot of work, so I didn't participate. But I will be completing this because I really want to learn, and this second lab was really interesting with the Cloud Vision API, and this is the one we'll be attempting. But when you click your avatar right here, you'll see that you have 0 credits when you first join it. So when you click this link and you open it, right, so there will be a sign in and a join button. So if you're already registered on Qwiklabs, you should join in, you should sign in, otherwise you should join Qwiklabs. And when you join, come back to this page, and you'll see that you have 9 credits right here. So you want to start one of these labs from the first quest, and you want to complete that lab. So after you complete that lab, you'll go back here and you'll see that you have 9 credits here. Then when you open it in a new tab, or the same tab if you want to, you'll see that you'll have the advantage subscription right here. So the advantage subscription is a 1-month subscription that gives you access to all of Qwiklabs. So this is a really great opportunity to learn. And hey, you can see my previous well, not a purchase because we got this for free, but we got 125 credits back in Cloud Study Jam last year. So you'll get the advantage subscription, and then you can complete all of CloudSeekho. So without further wait, let's get right into this second lab. I just completed this in the morning today. Then I got a little busy, but I was planning to do all of the whole quest. So let's see. So this is the APIs Explorer quick start. So application programming interface. So we're going to use the Vision API. So the Vision API has pre-trained ML models, so it will automatically assign labels and define your image into categories and objects and faces and text and so on. So it will detect what is in your image and will go through that. So whenever you start a lab on Qwiklabs, you'll see that you have this start lab button right here, and you have this timer. So when you start the start lab, you click the start lab button, the timer will start counting down. So you don't want to do this right away. You might want to, and here's the credit cost of the lab. You can see it on the previous page as well, the credit cost for each lab. But because we have a subscription, so we won't be paying credits to attempt the lab. So the first thing you want to do is you want to read the this lab manual, this sort of lab manual, and see what it has to offer, what the lab has to offer. So what are you going to do today with this lab? You're going to browse through APIs, you're going to see methods and parameters of an API, and then you're going to use that API to identify what's in your image. So there's some extra information here as well, and you might want to read that later. So what are we going to do exactly? We're going to create a cloud storage bucket. So we're going to create a bucket that will store our data, or basically the image that we're going to use and detect what's in it. And we're going to upload it and then make it public, and then we'll ask the Vision API to look at that image and tell us what's in that image. So first of all, this setup. Also, I want to quickly mention that the first lab I didn't attempt it because it did not have all these instructions, which was a little unusual. So that's why I chose the second lab as well. So you want to click the start lab, and that will start the timer. And you need to have a stable internet connection, and obviously the time to complete the lab, and the Chrome browser is recommended for Qwiklabs. So when you click the start button, I'm going to do it right now. Yeah, I'm not a robot, Google. So normally you see the use credits option right here, but because I have the subscription, so I'll click the use subscription button.
Hey, Talat,
Yeah,
Google recognized me as a person, so if you want.
Oh, so you can open. So
Yeah,
Qwiklabs is working.
it's already open.
Oh, okay. So Mehrose is going to help us now. Mehrose, kindly share your screen. Mehrose is our savior now. He's going to help us out. So we've got a small number of attendees now, but I think that's okay. We started off with more than 30.
Can you see the screen?
Yes, I can see the screen now. Okay, so Mehrose has started the lab, and this is great. So you can see he got the username and the password and the project ID. So Meros, scroll down to where we're going to start the lab.
Where?
yeah, just scroll down and I'll let you know. Right, right here is where you want to start. So you want to you want to click the open Google console button, so it'll open the Google console in a new window, in a new tab. So click the open
Wait, I
Google.
forgot. Okay. Oh yeah.
Yeah, right here. So you want to sign in. So Meros, no, not with your current account. You want to sign in with the account given to you by Qwiklabs. So go back. You want to close this
To
tab
my
and
email.
no, turn off. Close this tab. Go back to the Qwiklabs tab. Yeah, and you want to use the username and password provided to you by Qwiklabs. Yeah. So go. Yeah, use another account and not this one. You want to go back and use this account. Okay, great. And the password given to you as well. So now Meros is signing in to the Google account that has GCP access. So you don't want to go through these processes, just skip or confirm, because this is a temporary account. So it's gonna take a few seconds to load up, and yeah, we're getting there. So while it does that, you can go back to the Qwiklabs tab. Okay, so the Google Cloud Shell. So it's like a terminal where you can work and give commands to Google Cloud Platform. So Google Cloud Platform works through the command line and as well as the graphical user interface. So you want to activate the Google Cloud Shell first of all. So go to the GCP tab and click on that. Okay, you want to agree to the terms of services and agree on quantity. Do not accept the email updates because you're not going to be using this account. So in the top right, you can see the terminal button. In the top right, Meros. Yeah, the leftmost
Where?
button. The leftmost button.
Oh.
Oh no, the leftmost button in the top right section of the top nav bar. Yeah, this one, the activate cloud shell button. So it'll take a few seconds to open up, and you want to continue. Whereas you might want to hide that pop-up that meet.google is sharing your screen. Yeah, thanks. So now the cloud shell is allotting some resources to you so you can use the terminal, and now it's establishing a connection to the Google Cloud Shell. So you've got the activated terminal. Now go back to the Qwiklabs tab. So yeah, scroll down. Scroll down further. So these are a few commands which you can run to see which account is activated and which project is activated. We're not going to run these, but you can take a look that if you run gcloud auth list, then you'll see which account is active in that Google Cloud Platform window. Now scroll down. Similarly, you can also list the project ID. Now scroll down again. Yeah, more. So now we're at our first step. We want to create a cloud storage bucket to store the image that we're going to give to the Vision API to process. So you want to go to storage and then browser, and then you want to create a bucket. So go to your Google Cloud Platform window, and then you want to go to the storage section. It's the third section in the left nav bar. It's the third section. The third section, my
Third
Rose.
section, okay.
Yeah. So in here you want to go to storage, and then browser. Okay, now you want to create a bucket so we can store our data in the bucket. So in the top you have this blue button called create bucket. You want to create a bucket. So you can give your bucket any name, but as the bucket is going to be public, so you need to have a globally unique name. So let's suppose we'll call this DSC dash CloudSeekho dash 666.
Yes.
Yeah. So this is going to be our name, so I hope this is unique. This is probably going to be unique. Okay, so you can only use
Okay.
lowercase letters, so Maroj might want to fix that. You can use
Only
hyphens.
lower.
You can use hyphens. You can use
Oh.
hyphens. That was not a problem. Yeah, lowercase. Great. Now you want to click continue. So we're not going to mess with all these settings. So you just go to create the button, create the blue button, create. Yeah. So we've created our bucket DSC CloudSeekho. So you can see we're in the bucket right now. Now go back to your Qwiklabs tab, Meros.
Mm.
So you can see there's this check my progress button. So Qwiklabs has this check progress feature. So it is linked to your GCP temporary account it has given you, and it checks your progress and gives you a score. So Meros, you can click check my progress, and then Qwiklabs will verify if you've created the cloud storage bucket. And yeah, you've created it. So yeah, now this is something we're gonna do differently. So the Cloud Vision API is going to analyze the image that we upload to the bucket, and then uh, it'll tell you what's in that image when we use the Cloud Vision API. So when I did this lab in the morning, I used the same image that the Qwiklabs has provided to us, and named it demo image and saved it on my desktop. But Meros, let's try something different to see if it actually works. So
Mhm.
open a new tab and go to Google Images and search for search for anything.
I'll search for anything.
No, not anything, but something
Okay.
different, something that's not a dog. Maybe a cat is something you want to look for, or a dog.
Mm, let's go for a cat. Which one do you like?
Well, anyone you like. A cat is a cat. It's
Okay,
cute.
yeah, okay.
So you want to save this image,
Okay.
and you
What should
want
I name it?
uh,
Wait.
a name was specified. Sorry, you might want to check that. Kindly close this, cancel this saving window, go back to our lab window. Yeah, so you want to name it demo, no, the other one. Yeah, demo dash image. So
Okay.
this is what you want to name your image, and I hope it's a JPG file.
I don't think it'll be, but let's see. Demo.
By the way, I
iPhone.
answered all the questions in the sidebar, so those of you that ask questions, look at them, and then also everybody should look at them anyway,
Okay,
just because I
now.
think that's some good things to know.
Yeah, thanks Stephen for answering all the questions. uh, Now we'll Meros, have you saved the image? Yeah,
Yeah,
now you want to upload this image, the one that you've downloaded, so we can
upload.
you can see at the bottom right that the image is uploading, and it has completed uploading. Now go back to the lab.
Mm-hmm.
Okay, so you've uploaded the image, so you want to check your progress and confirm if you've completed this task, so it will provide you another score. So yeah,
Done.
you've successfully uploaded an image called demo-image.jpg. Now what you want to do is you want to make this image globally visible. So you want to make it public. You want for all users, but you want them as readers, not editors. So go back to your GCP window. Now click the three dots in the yeah. Now click the three dots. Not these ones. Arrows, not these ones. You might want to go back. Yeah, the three dots right next at the end of our image. Yeah, you want to edit permissions, and you want to add another entry. You want to add another entry, and you want to click this user. Yeah, you want to make it public. You want the entity to be available to the public and all users and reader. So now you want to save. So we've made this image publicly available to the internet. So now we can go back to our lab manual. Yeah, so now you can verify if you've made the image publicly accessible. So you can see in the top right that yellow scoreboard. So Qwiklabs gives you a score every time you complete a task successfully. So Meros has completed all the tasks that were necessary to complete the lab, but we still haven't used the Cloud Vision API. So you want to complete the whole lab rather than just get the whole score. So now we want to go to navigation menu and then APIs and services, or we can just search for Cloud Vision in the search bar. So go to the GCP console and then search for Cloud Vision in the top search bar.
Cloud Vision.
Yeah. So this is what you want to search for, and you'll get the Cloud Vision API at the top. So you want to select that, and you want to make sure that the Cloud Vision API is enabled. So it was enabled for me by default, but if it is not enabled for you, you might want to enable it. So it says disable API. That means that the Cloud Vision API is up and running. So now we can go back to the Qwiklabs, and now you want to go down, and yeah, so no, yeah, you want to open the Cloud Vision API link that they've given. So open this in a new tab. Right click it and open in a new tab. Okay, so it automatically opened in a new tab. So this is the cloud. Now wait a minute, a few seconds actually, and a window will pop up. Oh, I'm sorry, Mehrose. I was giving you the wrong link. So this is the link that we want to open. I'm really sorry about that. That was a mistake on my part. This is not the link that you want to go to.
It's okay.
This is the link that you want to go to. So it automatically opens this up. So we're going to try the Cloud Vision API here. So this is the request body where we'll give it the body parameters and tell us what we are going to do. So the first thing we want to choose is we want to go to our requests. Then we want to add an item. So then we want to add a feature. Okay, so we're going to add a feature. So in the features, we want to add an item, and the type should be label detection, because we're going to detect we're going to add label detection to our image and see what the image contains. So yeah, and also we're going to give the image source to our this Cloud Vision API. So we want to add it after the features area. So we're going to give it an image from source, and the source should be image URI, and here we want to give the URL of our image. So it should be something like this. Okay, so I'm going to copy it right here, but you need to replace the bucket name. So my bucket is not the bucket name that we have right now. The bucket name is DSC CloudSeekho 111. So I'm going to replace my bucket with this, and I think we're good to go now. And you want to make sure that Google zero auth 2.0 is checkmarked, and API key as well. So these are checkmarked, and then what you can see that we have the Cloud Vision call right here in these three files. And now when we click execute, the image will be sent to the Cloud Vision API, and it will now I'm requested to sign in with the account that I'm using for this specific lab. So I selected that account, and I allowed Cloud Vision API into my account, and let's see. the responses that we got. So it says that it's a cat, and it's a mammal, and it's a vertebrate, and it's got whiskers, and it's a small to medium sized cat. And Felidae, I don't know what that is, but it is some information about the cat. It's a tabby cat. So there's a facial expression to that cat. So we saw it was an angry growling cat. So it's a European short hair, and it's a carnivore. So you can see how detailed tags we can get using the Cloud Vision API, and it was able to identify our cat. So what else can we try doing right here? So we've still got quite a few minutes. So what we can do is we can try and execute this again, but we'll replace the image in our cloud storage bucket. I'm not sure if this will work, but let's try giving it a beer, or maybe let's try giving it a fish, so it's a completely different thing. So let's try giving it a goldfish, and we'll save this image, and we'll save it right here. We'll replace that, and we'll go back to our bucket, and we're going to how do we delete this image? Okay, we'll upload another file, and it's going to be demo image. So we're going to replace the existing object, and we are uploading it, and we have replaced this image. Let's check the permissions right now to make sure that okay, we have to add the permission. We're going to make it public to all users as reader, and we're going to save this image. So this is an image of a fish. So we'll go back to our Cloud Vision API, and we'll see that it has the same thing going on, and we're going to execute it again. And this time around we'll see that this is a fish, and it's a goldfish, and it's a feeder fish. It's orange, it has a tail, it's a bony fish, it's got a fin, it's a ray fin fish, and it's an organism. So you can see how Cloud Vision API works. I guess we covered the hands-on part, and we did a couple things. So when you're done with the lab, there's some MCQs that you can I hope all of you got how Cloud Vision API works. So we can close these windows now because we're done with the lab, and now there's a few questions that you might want to answer. So object names must be unique only within a given bucket. So this is true, but the bucket name should be unique globally. And then when an object is shared publicly, any user with knowledge of the object URI can access the object for as long as the object is public, and this is also true. So you want to make sure you don't put out sensitive information unless it's really required. So that's all, and we've completed this lab. So we can, and you see we've got a full score, so we can safely click the end lab button, and then you can give some feedback. So I am really satisfied with this lab, and I'll say that I had fun doing this lab and learned about image processing, and that's my feedback to Qwiklabs. And I'm done with this lab. So you can complete all the labs inside quests, and when you complete this quest for CloudSeekho, you might be eligible to redeem some swag. So we had some technical issues, so I really apologize again, and I'm really thankful to Stephen for joining us today and explaining how machine learning works and helping us out through the process, and really participating and explaining everything in a really nice way. And wait a second.
Cool. Yeah, good luck with CloudSeekho, everybody. And there's definitely some cool challenges in there. I was poking through it all, and get yourself some swag, and you'll learn a lot of really useful stuff in the process.